during lecture, people talking during rock concerts, my least favorite, and Celine Dion records. Anybody here willing to say that they like Celine Dion in public? All right, you guys are clusters up there. I kind of like her, you know, I don't know, she's so over the top that there's, you know, it's okay. I won't turn off the TV if she's on, but some people think more Celine Dion is a good thing. Other people think more Celine Dion is a bad thing. So I had a GSI for this class 2 years ago. She's Canadian. That has nothing to do with the fact, has nothing to do with the fact that she liked Celine Dion, but she played that crap all day long in her office, and it was right across from mine, so I had to listen to this stuff all day long. So she was more happy, I was less happy. Celine Dion, good for her, bad for me. Again, it depends on your preferences as to whether something's a good or a bad for you. Question? Yes. Yes. So, you know, if you're thinking about deforestation, who here thinks deforestation is a bad thing? Most of us, right? If you're allergic to tree pollen, man, deforestation is your best thing. Chop this thing down, right? So all I'm saying is, again, even if most of us think something is a bad, for some people it may be a good, and again, that depends on your personal preferences. Okay, here comes a tricky part. Can we represent preferences? I need one more volunteer. Why don't then I don't have to walk up here? You there in the back? I don't know you yet. Yeah, come on down. Do you mind? Are you allergic to peanut butter cups? No, because you asked for some. So they're good for you, not a bad. That's right. So last experiment for today. What's your name? Byron. Byron Max. Nice to meet you. All right, Byron, what I'm going to do is I'm going to give you a couple of bundles. I'm going to start with, don't look at the screen because I got to figure this one out. 5, 5. So 5 of each. 1, 2, 3, 4, 5. Oh, no, 5 of each. I think I may be running out of Reese's. This is bad. 1, 2, 3, 4, 5. Okay. So what I want you to do is stare at this pile of chocolate for a second. This is one of these meditation moments. What I want you to do is look at the chocolate and sort of really feel how happy consuming that chocolate would make you. It's almost lunchtime, right? So have you sort of recalled? It's like an emotional measure of just how happy would that make you. You got it? All right, excellent. So what I'm going to do now is I'm going to take away, what am I taking away this time? I'm going to take away some Reese's, okay? And what I'm going to do at the same time is add, speak slowly, Max. We have 5 each, okay? I'm going to add a Reese's to this pile. If I gave you 6 of these and 5 of these, would you be happier? Yeah, of course. I mean, who wouldn't be, right? So what I want to do is I want to get you back to that level of happiness that you were at before. I could get you back there really easily by just taking away that Reese's again. But I'm going to make this tricky. I'm going to take away some hugs, and I'm going to want you to scream stop as soon as I've taken away enough hugs for you to achieve the same level of happiness with 6 Reese's and however many hugs are left on the table. Got it? Yeah. All right. Stop. All right. Happens every year. So what we got is, right, we got 5, 5. Reese's, Hershey's. Then I added a Reese's. I subtracted a Hershey's. Same level of happiness. So let's go back to our original state, 5, 5. Okay. Now I'm going to give you an additional Hershey's, and I'm going to take away some Reese's, and you're going to tell me when you have the same level of happiness as you had at 5, 5. So 6 Hershey's, 5 Reese's. I'm not happy. You're less happy? Yeah. Do you want me to cut it in half? A quarter? I have to take something away, right? So how much of this Reese's could I cut away in order to get the same amount of happiness as you had before? The wrapper? I like the way you think. This guy's after me unwrapping the candy, so he doesn't even have to wait until he eats. Okay. So let's just do this. You're right. These are your preferences. I don't know. So what I had is 6 Hershey's, right? And we're going to go with 4.95 Reese's. Is that about fair? Yeah, that's right. Okay. Let's play this one more time. Okay. But now what I'm going to do is I'm going to go to a lot of chocolate. Let me just see what I have. Very happy. 7, 7. Okay. 7 Reese's, 2, 4, 6, 7 Hershey's. Again, stare at it. Record the level of happiness that you would get from this amount of massive chocolate carbohydrate overload. Did you record your level of happiness? Yeah, you're so excited you can't wait, right? But we're going to play the same game again, right? What I'm going to do is I'm going to, what did I do last time? I'm going to add a Reese's, okay? Holy schmoly. 8 Reese's. You're happier now, right? I can tell you like those a lot. I'm going to take away some hugs, and you're going to tell me when you're back to your level of happiness. So did I take 2 or 1? 1. You'll get everything in the end, by the way. Don't worry. You'll go home with a lot of chocolate. Okay, so we got 8 Reese's, 6 Hershey's, and now I think I know what the answer to the next one is going to be. I am a professional forecaster. 2, 4, 6, 7, 2, 4, 6, 7. Okay, what do? We add a Reese's, so now there are 8 Reese's, and there are 8 hugs, 7 Reese's, and I'm going to take away some Reese's, all right? Yeah, you're less happy, but if I just took off the wrapper, you'd be okay again? Okay, all right. So what we'll do here then is we will again note 6.95 Reese's and 7. I'm going to send you home with this chocolate here. Can you carry all this, or do you need a bag? Here's a bag with some extra Reese's in it. Hand some to your friends, will you? Thank you so much. So what I want to point out here, and because my computer doesn't work with this screen, unfortunately, usually I live edit this thing, is I started with a medium level of happiness, right? 5 each. Then I add a hug, and the person that answered this table was a different person with different preferences that let me take away 2 Reese's until they were at the same level of happiness. So they were indifferent between 5, 5 and 6, 3. For Byron, right? That would have been not 6, 3, but 6, 4. The third experiment here would have been I took away a hug. How many Reese's would I have to add? I would have had to add 3 Reese's, all right? Different preferences from the ones we see on the board here. Does this person like hugs more than Byron did? Much, right? So they have a relatively stronger preferences for hugs over Reese's than Byron did just now. Now, if we're looking at the bottom table here, these 3 rows, I have 7, 7, right? I start out with an allocation of 7 each. Then I add a hug, and I take away some Reese's until this person is indifferent between having 7, 7 and 8, 5. So I got to take away 2 Reese's right here. Here, that experiment resulted in 6.9, 6.95 and 7. And the other experiment here is I looked at an indifference point. So this should, of course, be a 7 right here. Come on, Max. 7, and I added. Oh, no, I was mean. I was mean with this person. I took away 2 hugs, right? And then I added Reese's, and I asked them, when are you indifferent between having 7, 7, and 5 hugs? Whether I take away 1 or 2 doesn't really matter. I just want bundles that are equivalent. I did the same experiment again. I know this is excruciatingly boring, but I swear I have a point. At a much lower level of happiness, where I start with 3, 3, and then take away 1 and fill in the other, and then take away 1 of the other and fill in the other. So what I have here is I have bundles A, B, and C, right? They're combinations of Reese's and Hershey's that the individual is indifferent between. I have D, E, and F, which are much lower combinations of the goods, but again, 3 bundles that the individual is indifferent between. And I have a very high level of consumption here, 7, 7, which are 3 bundles the individual is indifferent between. So I don't care whether I get G, H, or I. I don't care whether I get D, E, or F. I don't care whether I get A, B, or C, right? Within these 3, I'm indifferent. But do I prefer A, B, and C to D, E, and F? Yes, by more is better, right? Do I prefer G, H, and I to D, E, and F? Yes, right? 7, 7 versus 3, 3. Do I prefer G, H, and I to D, E, and F? Yeah, you do, right? So you have a lot, you have a little here. So you prefer these to these. But you're indifferent between these 3, indifferent between these 3, and indifferent between A, B, and C. But bundles D, E, and F are less preferred than bundles A, B, and C, which again is less preferred than bundle G, H, and I. Okay? I'm quickly going to sketch on the blackboard what these look like. I'm getting a fancy tablet that I can draw this on next time, but let's graphically represent this quickly, then we'll do attendance very, very quickly, and then we'll call it a day for today. So tables are, generally speaking, if you've ever worked for a consulting firm, a very inefficient way of presenting information. A graph beats a table any day of a good graph beats a table any day of the week. I just went through an exercise of 3 years of bad graphs. Bad graphs are bad. But can we represent this information on the board in a way that actually conveys the same information but teaches us something? So I'm going to put Reese's on the y-axis and Hershey's on the x-axis, and I'm going to do what you could do in Excel in 3 minutes. If you don't know Excel, go learn it. 1, 2, 3, 4, 5, 6. You don't have to learn Excel for this class. It's a life skill. Okay, so we're going to plot these bundles. A is 5, 5. So this is bundle A. Bundle B is 6, 3. 6, 3, roughly here. And bundle C is 4, 8. 5, 6, 7, 8, and 4. Okay, I'm indifferent between these 3 bundles. Now I'm going to plot C, D, and F, right? I start at, D, E, and F. At 3, 3, this is D. E is 4, 2, 4 hugs, 2 Reese's. And F is 2 hugs, 5 Reese's. Roughly here. This is F. Last one. Now I'm going to do G, H, and I, 7, 7. This should be G. H is 8, 5, 8 hugs, 5 Reese's. And I is 5, 10, somewhere up here. So what I'm indifferent between is I'm indifferent between F, D, and E. I'm indifferent between C, A, and B. And I'm indifferent between I, G, and H. But I prefer these points to these points, and I prefer these points to these points. Now, I could play the same experiment we just did in front of the classroom by taking little, get a truffle slicer and slice little slivers of peanut butter cups. Take a sliver away and figure out how many slivers of hugs I would have to add in order to stay indifferent. I just took away discrete quantities to trace out 3 points. We could do this with 1,000 different bundles that the person would be indifferent between. If we did that and connected all of those points, you would get something that looks like this. They're these sort of half U-shaped curves right here. They're curves where on each curve, you're indifferent between all the bundles that this curve represents. I'm indifferent between F, D, and E, but I'm also indifferent between F and this point, and this point, and this point, and this point. On the second indifference curve, I'm indifferent between C, A, and B, but I'm also indifferent between C and any other point on this indifference curve, which we didn't trace out by an experiment because it would have taken forever, but we could have. The third indifference curve right here, I'm indifferent between I, G, and H, but I'm also indifferent between G and any other point on this indifference curve. The other thing to note here is, of course, am I indifferent between H and B? Which one do I like better? Correct. Am I indifferent between B and D? Am I indifferent between, yeah, that won't work. Oh, yeah, that would work. Give me a point. I'll call this Max for, bundle Max 8 for breakfast. Am I indifferent between A and Max? One person said yes. The answer is no. All right. So let me make sure we get this correct. A is on a higher indifference curve, meaning I prefer C to A to B, right? But I prefer A to D because here's 5, 5 to 3, 3. That means any bundle on this indifference curve is preferred to any bundle on this indifference curve, right? And the trick why you said yes is this distance to the origin seems longer than this distance, right? If you're not going to use the shoelace, you're going to get in a second, all right? But look at the distance, right? A is closer to the origin than this max point. How could you prefer A to max, right? It's not how far from the origin the bundle is. It's on which indifference curve in terms of how far from the origins on a strong ray or a simple ray from the origins the indifference curve is, all right? So points on indifference curves further away from the origin are preferred to points on indifference curves closer to the origin. So the way you judge which one is most preferred is draw a straight line from the origin to anywhere in these coordinates and label it, this is my least preferred, second least preferred, most preferred, right? It's not absolute distance, it's what indifference curve is furthest away from the origin on a straight line, the same straight line. All right, next time we're going to do this quickly again and then very quickly get into some pretty complicated material. So this will be exciting. 5 minutes. Okay, I'm going to read last names quickly. So you're going to pay attention and you're just going to say yes. If you feel like you were missed, just see me after class. All right, on. Another